Hi all, welcome to another video of subject power system analysis based on the KTU syllabus, and today uh, we will discuss a problem based on the Gauss-Seidel method of load flow analysis. So the problem is the system data for a load flow solution are given in table 2.11 and 2.12. Determine the voltages at the end of first iteration by Gauss-Seidel method. That's the problem. So here in the first table the line admittances are specified, that is from the table itself we understood that it is a 4 bus system because 4 buses are there, 1, 2, 3 and 4. Okay, and the admittances in between the buses are specified here, that is in between bus 1 and bus 2 we are having the admittance 2 minus j8, like that. Other buses are also specified here, and in the second table the bus 1, okay, actually the bus 1 is a slack bus. It is given it as a slack bus because only the voltage is specified there, and other 3 buses are PQ bus, that is we can call it as load bus. Okay, so for a load bus we know that the real power and reactive power, okay, P and Q, okay, will be specified. So here they are specified, and the bus number 2, 3 and 4 are the load buses. Okay, and we have to find the voltages at the end of first iteration. So the initial step is to construct a single line diagram, okay, based on the given table. So the single line diagram means here 4 buses are there, and between these 4 buses some admittances are there, so we have to mark it down correctly. Okay, so between bus 1 and bus 2 the admittance is 2 minus j8. So here we have first we will draw 4 buses, 1, 2 and 3 and 4 buses we will draw. After that we will connect the admittances in between that. So here for between 1 and 2 it is 2 minus j8, so we have connected 1 and 2 and written here 2 minus j8. So it is denoted as small y12. It will be, of course, it will be equal to y21. Okay, and also between 1 and 3 we are having 1 minus j4, 1 and 3 we are having 1 minus j4. So like that we can connect all other admittances here. So at the end we will obtain a single line diagram. Okay, and from the single line diagram we have to construct the y bus matrix. Okay, y bus matrix means the admittance matrix means y11, y12, y13, y14. It is a 4 bus system, so 4 rows will be there and 4 columns will be there for a y bus matrix. Okay, so we have to find each and every element of the y bus matrix. So y11, okay, first y11, we know that y11 means the sum of the impedances connected to the first bus. So here the impedances, admittances connected to the first bus. So here the admittance are 2 minus j8 and 1 minus j4. So we have to add them together, 2 minus j8 plus 1 minus j4. Okay, so here capital y11, y12, y22, y33 are the elements of the y bus matrix. Okay, and the small y12, y13 are the corresponding admittances between the matrix specified as per the problem. Okay, as given in the problem. So y11 we have to add all the admittances, and like that we have to find, we can find y22. So here y22 means we have to add 2 minus j8 plus 0.66 minus j2.664 plus 1 minus j4. Okay, so we will obtain y12, that is small y12 plus small y23 plus small y24. Okay, like that. So we can find all other y33 and y44, and after that we can find y12, capital y12. y12 means always these elements, that is y12, y13, y14, okay, will be the negative of the corresponding admittances connected in between the buses. So capital y12 means minus of the admittances connected between 1 and 2. So here it is 2 minus j8, so the capital y12 will be, okay, capital y12 will be minus of 2 minus j8, that is minus 2 plus j8. Okay, so here you can see y12 is minus 2 plus j8, minus of 2 minus j8. Okay, so like that you can find all other values. Here the y1 4, okay, there is no element connected in between this y1 and 4, so y1 4 and y4 1 will be 0. Okay, and after that we have to write the y bus matrix like that. Okay, and after finding the y bus matrix, we will start the iteration process. So for starting the iteration process, we have to assume the initial values of the buses. Actually we have to find the bus voltage, so we are assuming the initial values of the buses. Okay, so the bus values, that is v20, v30, v40. Okay, 0 means it is the initial values. Okay, and 1 means if instead of this 0 if it is 1, it means it is the first iteration value. Okay, so here we can write the initial values of v20, v30, v40 as 1 plus j0. So here v10 is not specified. Why? It is because v10, that is the first bus, is a slack bus. Okay, it is given in the question itself, that is first bus is a slack bus. So here the voltage of the first bus is specified, that is 1.06 angle 0 degree. So it will not change. Okay, it will be keep on that value for any number of iterations. Okay, so the voltages for the first bus is 1.06 angle 0. Okay, so that we can see here, that is v10. The bus 1 is a slack bus, and so it is voltage remain the specified value for all iterations, which means v10, v11, then v12, v13. Okay, all other values are 1 plus 1.06 plus j 0 per unit. Okay, so since the buses are PQ buses or other buses are PQ buses, the specified real and reactive power are considered as load powers. Okay, therefore a negative sign is attached to the specified power. That is actually for a pure load bus. Okay, pure load bus, the real and reactive power are considered as negative, because we know that load is consuming the power. In that sense, we can assume the power is negative. But for a pure generator bus, the real and reactive power are always considered as positive, because the generator bus means it's generating the power. Okay, so we are taking it as positive. Okay, and in some cases, some buses in a particular bus, both the load and the generator will be the, okay, so in that case we have to take the difference between the generation minus load. Okay, we have to take that power. So, and for finding the next iteration value, that is here the first iteration value of the first bus, that is v11. Okay, it is 1.06 j0 per unit. Okay, and like that we have to find, okay, we have to find v21, v31 and v41. Okay, v41, that is the first iteration values of all other buses. Okay, if we can find these values, the problem is solved. Okay, so first we can find the y21. For finding the y21, the equation we have to follow is like this. That is the k plus 1th iteration voltage of a PQ, that is load bus P, is given by Vp k plus 1 is equal to 1 by ypp into pp minus j qq by Vp k star minus sigma q equal to 1 to p minus 1 ypq vq k plus 1 minus sigma q equal to p plus 1 to n ypq vq k. Okay, so this is the basic equation. All of you must learn this equation as well. Okay, we have to use this equation for number of problems. Okay, and here for first iteration, for getting the first iteration values, the value of k should be 0. Okay, so like that we can find the bus voltages. So we have to use this equation clearly. Okay, so here one mistake is there, that is in the equation itself pp minus j, it is written as pp minus j qq. It is not like that, it is p minus j qp. Okay, for the bus number p, okay, it will be pp minus j qp. Okay, so here it is a 4 bus system, so the values of p, okay, p will be 1 2 3 up to 4. Okay, and we can start the iteration process. So first the first bus is a slack bus, I have already said that. So the first iteration value of the slack bus, the voltage value Okay, we need not to compute that. Actually we can write it simply as v11, okay, which is equal to v10. That is, v10 is the initial value we have assumed, sorry, initial value it is specified in the problem itself, okay, that is equal to 1.06 plus j0 per unit. Okay, in the question it is given as 1.06 angle 0, 1.06 angle 0, which is in polar form. Okay, so if you are writing it is in rectangular form, the equation will be like this. And for finding v21, okay, that is the first iteration value of the second bus, that is v21, the equation will be from this equation itself, v21, that is the value of k is equal to 0 here, okay, and the value of p is equal to 2, okay, value of p is equal to 2. So v21 is equal to 1 by ypp, that is 1 by y22 into pp minus jqp, it is qp, okay, jqp. So pp, p means 2, so p2 minus jq2 by v2k, okay, vpk, k is 0, so v2 0 star minus y21, okay, so here, and here the value of q will be q equal to 1 to p minus 1. So here the value of p we are assuming it as 2. We have to find the second bus voltage. So p is equal to 2. So p minus 1 means 2 minus 1. Okay, p minus 1 means 2 minus 1 is equal to 1. So the value of q will be 1 for this case. Okay, this case. So that is p is equal to 2 and k is equal to 0. Okay. So here the ypq means y21. Here you can see y21, and vqk plus 1 means q is 1. So v1 1, v1 1, k is 0. Okay, so that's all. So here and the next time is, here the values of q is only 1 because q is equal to 1 to p minus 1, p is 2, so 2 minus 1 is 1, so we can assume the value of q as 1 only for this case. And for the next one, sigma equal to q equal to p plus 1 to n, okay, 1 to n, okay, so then n is 4, so q will be p plus 1, so 3 and 4. The value of q here will be, okay, q can be p plus 1, p is 2, so 3, okay, and 4, okay. So here you can see ypq, y23, then vqk means here we are considering q as 3 here first case, so v30 minus, okay, minus, then the value of q is taken as 4, okay, values of q is taken as 4, and ypq means y24, then vqk, that is q is 4 here, so v40, okay. So this equation for v21, and just substitute, we know all these values, okay, all these values we know, just substitute that values, y22 we know, and p2, okay, p2 and q2 it is given in the question itself, that is for second bus, okay, p2 is 0.5 and q is 0.2, so we have to take the negative of that values, okay. So here in the question itself, p2 minus jq2, so p2, okay, p2 is taken as minus 0.5 because the p value for the second bus is 0.5. We have to take the negative value because it is a load bus, the load is consuming the power, so we can assume a negative value there, okay. And q is also negative, so here already a negative sign is there, so it becomes a positive sign here, okay. So minus 0.5 j 0.2 by 1 minus j0 v20, we know that, okay. And y21, v11, y23, v30, all other values we know, just substitute the values and compute, okay, clearly, okay, clearly and accurately, don't make mistake, okay. And at last we can find the real values, okay. That is for dividing this numerator with the denominator, we have to convert these rectangular coordinates into polar form, okay. And after that, we by dividing each other, again we have to convert back that into rectangular form. So y21 will be 1.0119 minus j 0.0290 per unit. Okay, so here we have to calculate the accelerated value of v21. Okay, that is, we will use an acceleration coefficient alpha here, that is for faster convergence. Okay, for getting a faster convergence we have to use an acceleration factor. That acceleration factor is given in the question itself, that is alpha is equal to 1.6. so we have found the y21 value here, and using this y21 value we have to calculate the accelerated value of this y21. Okay, so v2 one accelerator will be v20 plus alpha into v21 minus v20. So this is the equation. v20 are the initial values of the second bus, and v21 is the first voltage value of the second bus after the first iteration. Okay, all these we know, v20, v21 we have found. Okay, just substitute that values and we will obtain that v2 accelerated as this one. Okay, so this is treated as a v21, actual v21 value. Okay, the accelerated value of v21 is treated as a actual v21 value. Okay, it is also here it is specified in polar form. Okay, so like that we can find the all other. So we can find v31 as using the same equation. Just substitute the values here. Okay, we can use the same equation here, vpk plus 1. Okay, so here the values of p will be, okay, listen carefully, the values of p will be 3 here. Okay, and the values of k is same as 0 because we are converting the first iteration. Okay, first iteration value. And here the only thing you have to note clearly is the value of q. Okay, here the value of q for the first case. Okay, for this case q is equal to 1 to p minus 1. So here the value of p we are treating it as 3. So 3 minus 1 means it is 2. Okay, so the q is equal to 1 to 2, that is q can be treated as 1 and 2 for this case. Okay, and for the next case, okay, for this one, okay, this one it is q is equal to p plus 1 to n. Okay, p plus 1 to n. So here the values of p plus 1 means 3 plus 1, it is 4. Okay, so here for the second case q can be 4 only. Okay, n is 4, so up to 4 we can compute. Okay, so that thing you have to note down. Okay, so here we get the equation as y31 v11, y32 v21, and y34 v40. All values we know, just substitute their values and find the value of v31. And like that, v3 acceleration, we have to calculate the v31 acceleration as v30 plus alpha into v31 minus v30. All that values we know, just substitute their values and find the v31. Okay, and v41 we can use the same equation. Okay, same equation, just should be careful while we are selecting the value of q for the two cases. Okay, and v41 we can find also you can use the acceleration values of alpha is equal to 1.6 here, and we can find the accelerated value of v41, and it is chosen as the actual v41 here. Okay, so it is the end of the first iteration. So in the question itself they have asked to find the first iterated values of the buses, all the 4 buses. So as a result we can write the all the 4 values of the buses after first iteration. Okay, v11 it is the specified value of slack bus, and v21, v31, v41 we have found these values. I hope all of you understand the problem well. So thank you.